Hello, and welcome to the Sheet Metal Design Buyer's Guide. Designing sheet metal parts presents many unique challenges, and these challenges exist across many industries, from electronic enclosures to machine guarding, industrial machinery, transportation, and consumer products. The sheet metal design process demands a unique set of tools that differ from traditional machine design or consumer product design. Everything from the material selection to the manufacturing process is unique to this dynamic industry. To maintain a competitive edge, choosing a new 3D design tool is definitely the way forward, but you must ensure that any new system meets the requirements for your business now and into the future. There are many benefits to designing sheet metal parts in 3D. It's easy to visualize your design. It's easier to make design changes. And most importantly, all downstream deliverables like drawings and manufacturing information are always up to date. So how do you choose the right solution? This buyer's guide will take a look at some typical design scenarios to demonstrate a cross-section of capabilities that are important considerations when making your decision. SOLIDWORKS provides the design solution of choice and is trusted by thousands of companies around the world to help tackle complex design challenges and to help get their products to market faster. Your CAD tool should not limit your creativity. You need the flexibility to create sheet metal parts in the manner best suited to the job in hand. We'll look at top-down assembly design later, but for now, we'll concentrate on the basics. Material selection should be your first consideration. In sheet metal design, we are often forced to adhere to certain requirements, such as standard materials and in-house standards for manufacturing and tooling. You need a simple way to make sure you comply with those standards. SOLIDWORKS offers a customizable gauge table, which contains only the materials, thicknesses, and bend radii that are readily available in our shop, so there's no need to look it up each time, and you'll keep tooling costs to a minimum. One of the most common features in a sheet metal part is an edge flange, so creating them must be painless. It should be as easy as dragging an edge to size, and when multiple edges are selected, the corners should be automatically mitered. The bend angle, miter gap, and flange position should also be very easy to control. Edge flanges don't always run the entire length of a part, so make sure the profile of each flange can be easily modified to fit your application, and bends and reliefs are added where appropriate. Modifying the length of a flange is not enough. You need to have the flexibility to create custom flanges without having to add additional features to complete the task. For instance, SOLIDWORKS lets you edit the shape of the entire profile and even add holes all in one go, and then modify it even further with an offset to add or remove material in the bend area. This saves a great deal of time and effort to get to the finished design fast. SOLIDWORKS also makes light work of features like jogs, enabling you to create them quickly by simply sketching a line and adjusting the offset and angle values. Many CAD tools can create basic flanges, but more complicated flanges can be challenging. You should ensure that your new software is able to create complex flanges with ease. In SOLIDWORKS, this is accomplished by sketching the required cross-section and sweeping it along a number of edges. Start and end offsets can easily be added, and the corners are automatically mitered. If you need to reinforce an edge or remove sharp edges, then you're going to need to add hems. Hem types, such as open, teardrop, rolled, and closed, should cover all your requirements. Of course, sheet metal design is not all about creating bends. Ventilation holes, mounting features, and strengthening ribs all play a part in the final design, so these should be simple and fast to create. SOLIDWORKS comes with a customizable library of pre-configured forming tools, such as embosses, lances, louvers, and ribs. The library also contains many common sheet metal fasteners like PEM nuts, standoffs, and studs. Custom libraries can be created to match your in-house tooling and are applied to the part with a simple drag and drop. As we add this louver set, it's easy to see and toggle which side of the tool is struck. Material is deformed and lanced as defined by our standard form tool. Simple. Ventilation holes are common in sheet metal enclosures, so it must be easy to add perforations to your parts. SOLIDWORKS fill pattern is perfect for this application. You can create your own custom hole pattern or let SOLIDWORKS create various hole styles for you. Size, spacing, stagger angle, and keep-out areas give you a variety of pattern styles to suit your needs. Now imagine if you had to create all those holes manually. A great design is no good unless it can be manufactured, so you need an accurate flat pattern. How the material deforms around bends must be accurately calculated and added to the lengths of the straight sections. As SOLIDWORKS flattens the part, bend lines, and blank size are automatically added, and the form features are maintained in their proper location in the flattened state. Note that the overall length of the blank is just over 361 millimeters. But what about changes? Let's change the default bend radius and also change the way SOLIDWORKS determines the developed shape. Flat patterns can be calculated by using a bend table, K-factor, bend allowance, bend deduction, or bend calculation. Bend calculation tables are very important, as you can define different angular ranges, assign equations to those ranges, and calculate the developed length of the part. Changing the way bends are calculated changes the blank size. It's now a small but significant 1 millimeter shorter. CNC punch presses, laser profilers, waterjet cutters, and offline CAM programs typically take flat pattern profiles in DXF format. SOLIDWORKS lets you directly export the flat pattern, bend lines, form features, and blank size, then present you with a preview window that can be used to clean up your output. Layers are automatically created for up bends, down bends, and blank size to properly communicate your part to the fabricator. Sheet metal parts rarely exist on their own, so a fully featured, robust assembly environment is a must. In this SOLIDWORKS assembly, there are a couple of components that need to match the size of our box. There is a curved brace and a lid that is sized to fit on top. These parts were built by referencing the geometry of the box. Consequently, as the size of the box changes, the lid and brace follow and update accordingly. The length of both of these parts changed automatically. But this isn't magic. Let's take a look at how it is done. There is a tab on the lid that needs to match up with the tab on the box. Let's edit the flange profile and use the edges of the flange on the box to form the shape of the flange on the lid. This is all it takes to establish a relationship between two parts. We also want the tabs to be flush with each other, so let's add an offset. But instead of inputting an offset distance, we can choose the offset to match the surface of the tab on the box. It's that easy. Now, as the tab on the box is changed, the tab on the lid follows. This is called top-down assembly design, and is one of the most powerful benefits that SOLIDWORKS brings to the market. Drawings still play a big part in communicating your design to manufacturing and your customer, so you need a best-in-class tool to do the job quickly and efficiently. Not only does SOLIDWORKS allow us to create highly detailed drawings of the part, but flat pattern drawings can be quickly created as well. Any unused views of the part are presented in the View palette, and they can be added to the drawing by dragging and dropping. You may notice that there are various colors on the drawing. The colors can be customized to represent up bends, down bends, hems, and form features, and can be very useful when exporting information to manufacturing. Bend notes are added to each bend, indicating the bend direction, angle of bend, and bend radius. We can quickly add a variety of dimension types. For this part, let's add some ordinate dimensions. In no time at all, we can have a fully detailed flat pattern drawing that is ready to be fabricated. Some parts offer additional challenges to the modeling techniques you've seen so far, and if your company has these requirements, your CAD software must be up for the challenge. The market is demanding smaller and more aesthetically pleasing designs, so you want your design tool to meet those requirements. For instance, the cross brace in our assembly is curved, and to add the required stiffness to the part, you need to be able to create a curved edge flange. Of course, manufacturing is going to demand the flat pattern, and with SOLIDWORKS, this is a breeze. More complex shapes like bins, covers, or hoppers can be tricky due to the compound angles required for its function, so your design tool must provide a way to create them in an efficient manner. For these parts, SOLIDWORKS provides an alternate creation technique where we can start with a solid part and quickly turn it to a sheet metal part. Think about wrapping sheet metal around the outside of the solid. Start with a fixed face, then choose the edges where you want bends. SOLIDWORKS intelligently adds rips to the adjacent edges. Material can be added inside or outside of the selected face, and all sheet metal parameters can be adjusted. Notice the nice job SOLIDWORKS has done in corners where these compound angled faces come together. Regular sheet metal features can be added, and of course these parts can be flattened and readied for fabrication. Finally, in some industries, transitions are commonplace and offer additional challenges, such as this oval to round part. Don't settle for a CAD tool that is not capable of creating and flattening a variety of complex transitions. Consider this chute that transitions from 5 linear edges to a round. It's flattened easily with full control over the number of bend lines that are added. With SOLIDWORKS, there is no more guessing or trial and error when creating ductwork, and of course fully detailed drawings can be created for fabrication. Selecting the right tool for your design needs is no easy task. This buyer's guide highlights many areas that are important considerations when looking for quick and efficient design of sheet metal parts and assemblies. We hope you have found it a valuable resource. To find out more information on how SolidWorks can help you overcome your sheet metal design challenges, please contact your nearest reseller or request more information on the SolidWorks website.